Hello everyone, welcome to the next lecture on the optimization techniques. Today I will explain you the new method named as Big M method. Myself Dr. Harish Garg. You can follow my YouTube channel for finding the various lectures on the optimization techniques. Now what we have discussed so far, we have learned the concept of the simplex methods and their respective examples. How you can find this lecture, you can find my YouTube channel Dr. Harish Garg, and the playlist is optimization techniques, and you can see the lecture related to the simplex method is uploaded here. You must watch this lecture to understand the today's lecture very well. I hope you can like and comment on the video as well. We all know the goal of the simplex method is your target is to find the optimal of the solution. As I discussed that the simplex method is of the two category. The type 1 is when all the constraints are of less than equal to form, while the type 2 is when at least one of the constant is greater than form. And this lecture, that is a simplex method, is applicable only when all those constraints are of less than equal to form. Whenever at least one of the constant is either greater than form or is equal to form, then we can use either the two-phase method or the big M method. You can choose any one of them. In this lecture, I will explain you the concept of the big M methods. For example, if you look about these two problems, you can see the first constant is of the greater than sign. So that means this problem you can solve either with the help of the two-phase, or you can solve this problem with the help of the big M method. Similarly, if you look at the constants, the one of the constant or the both the constants are equality form, again you can solve the problem either by two-phase or big M method. So in this lecture particularly I will solve with the help of the big M method. In the next lecture when we discuss about the two-phase, I will explain the same problem and solve this LPP again with the help of two-phase method. Again, if you look about all these four examples that I will explain you in this lecture, again you can see the constant is of the greater than sign, it's equality, one is equality, and both are equality. So all these problems can be solved with the help of big M method. But if you look about the fourth example, the objective function, either the maximization or the minimization, is not given to you, or you can say this is missing. Then how you can solve the problem in which objective function is not given? Again, you can solve the problem with the help of big M method. So I will explain you all with the help of the numerical example in this problem. Always remember, whenever you are using the simplex method, whenever you are using the two-phase method, or you are using the big M method, your target is always convert the minimization problem into the maximization problem. Like if you have the minimization 2x1 minus x2, then your target is to convert into the maximization problem by reversing the sign, minus 2x1 plus x2. Once you consider the problem as a maximization problem, then the step number one is you can write in the standard form, find the entering variable, leaving variables, and so on. And all these steps are similar, or you can say are the same as we have explained in the lecture of the simplex method. That's why I request you, you must watch this lecture firstly so that you can understand this lecture in a couple of the seconds. Dear student, don't forget to like and share this video with your friends. First of all, can you solve this problem with the help of the big M method? Yes, because one of the constant is greater than 0. So your target is to write in the standard form. Always remember, whenever the constants are of the less than sign, you can write as the plus S1. Whenever the constant is of the greater than sign, you can write as the minus S1 plus A1. Whenever the constant is of the equality form, you can write only as the A1, where A1 is my artificial variable. Fine. For more detail about this standard form, you can watch about my this lecture, canonical and the standard form of the LPP, which is present in this playlist. Fine. You can find this journal form of the LPP. It's a very beautiful lecture. You can learn very easily. Now, you can write in the standard form firstly. So maximization, subjective. So because the constant is of the greater than sign, so you have to write minus S1 plus A1. Similarly, for the second constant, it is of the less than sign. So I can use only S because S1 is already there. So it's my S2. Similarly for the S3 for the third constants. So all xi's are my greater than 0. S1, S2, S3 are my greater than 0, as well as A1 is also greater than 0. Your maximization problem is minus x1. Because one A1 is present, your target is to write as a minus M A1. If you have one more A2, then you can write as a minus M A2 as well. If you have the more than one artificial variable, where M is a very, very large number. Fine. Very, very large positive number. You can choose M is my 100. You can choose M is my 1000. You can choose M is my 10 raised to power 6. That's on your choice. That's why this method is called as the big M method. M is always the positive larger number. Fine. Now you can write in the standard form. You can see here. So how many variables you have? You can write as a x1. Second is x2, s1, s2, s3, a1. Now you can substitute the value. What is the x1 in the constants? 2. You can skip the first column, first row. X1, 0. X2, 1, 1, 1. S1, minus 1, 0, 0. S2, there is no S2, 1, 0, and so on. Right hand side will be my 2, 3, 4. This is 0, 0, 1. A1, A2, A1 in the first row, and so on. Fine. Now you have to write these three answers. Look at the how many constants? Three constants. What is the identity matrix? 1 0 0 0 1 0. Now look at this column. Do you have the 1 0 0 column in this case? Yes, this is my A1. Write the first column as a A1. Second is the 0 1 0. 0 1 0 is corresponding to AS2. 0 0 1. 0 0 1 is corresponding to the S3. So you have to write A1, S2, S3. Fine. What is the value of the A1 in the objective function? Coefficient minus M. S2, there is no S2, 0. There is no S3, 0. What is the objective function value in the x1? 3. This is the value of the Cj. X2 minus 1, S1 0, 0, 0 minus M. Fine. Now, your target is to compute this value. Whatever the value A1, always write as a 0. S2, 0. S3, 0. Fine. Now, how you can compute this value? It's very simple. Multiply them. Minus m into 2 plus 0 into 1 plus 0 into 0 minus this is the value of zj. This is the value. Minus cj. This is the value corresponding to the x1. So what will be the answer is minus 2m minus 3. So that part is my minus 2m minus 3. Similarly, you can write this number. It's a minus m plus 0 minus upper value. So this number will be my minus m plus 1. Similarly, for this case, it's a m plus 0 minus upper value 0. This is m. Look at the last value. It's a minus 2m plus 0 and there is no other number, upper number, so there is no need to write something. So it will be my minus 2m. Is it okay? Now once you have completed this table, the rest of the calculation is very simple. Now look at the value of the zj minus cj. Pick the value which has the largest negative value, which has the largest negative number. So you can choose m is a very large number. Say m is my 100. Fine. So this number will be my minus 203. This number will be my minus 99. This number will be 100 and so on up to this. So which one is the largest negative? Only 203. So that number is my entering variable. Fine. So that number is my entering variable. So you can put the arrow inside it. Fine. Once you put the arrow in this case, find the ratio. How you can find the ratio? Look at the column of the solution and the entering variable. Find the ratio of only those terms in this column which has the positive value, like 2 divided by 2, 1. 3 divided by 1. Because it is not a positive number, it's a 0, so you can't find the ratio. Fine. Which one is the minimum ratio? Which one is the minimum value? It's a 1. So that means you have to leave this column, enter this one. So this number is my, which one is the intersection? This is my entering variable. This is my leaving variable. So value of the 2 is my pivot element. So you can replace this xa1 and enter the, instead of the a1, write as the x1. Fine. Now repeat the process. This is the x1. You can write as a first identity matrix. S2 second column 0 1 0, x3 0 0 1. Write the value corresponding to this is always 0. Fine. Now it's a box element. Divided this complete row by the box element. It's a 1. It is divided by 2. Fine. 0 0 1 over 2 and 1. Is it okay? Fine. Now how you can compute the rest of the values? It's a very simple. For example, if you want to find this number, what is the previous value of this? 0. Always look about the 4 numbers. One is the box element, second is the position, and if you look about these 2 numbers, try to form a box. Fine. Try to form a box. If I consider 2, then this is the 1 and this is the 1. Box is always with the closed form, not look like this one. Fine. So if I consider 2, then 1, then 0, and then 1. So this is my box. I can write this number is 2 1 0 1. What is the box element is? Here. Find the determinant of this, but always start from the box element. Start from the box element. So it will be 0 minus 1 divided by box element. It is my minus half. So this value will be my minus half. Is it okay? Now, if you want to find any other number, say let's say you want to find this number. What is the previous value is? Minus of 2m. Fine. So I can start with a box. One number is 2. Second number will be minus 2m minus 3. And other number is my 2. Fine. You can start the determinant, start from the box element. So it will be my minus 4m and it will the opposite sign. It is plus 4m plus 6 divided by box element. So it answer is 3. Similarly, you can find any other number like say this one. What is the previous number is 0. 1 is the 2. Second number is my 1 and minus 1. Start from the box element. 0 minus minus plus 1 over 2. This number is my 1 over 2. Similarly, if you want to find this number, box element is 2, other number is my 0, and the other points are, one point is this, 0. So start from this is a 0. It is my plus 0 divided by box element. It is my 0. You can find any number, say here. What is the previous number is? Minus m plus 1. Fine. One is previous number is this. One is the 1 and second is it. So you can write as a minus 2m minus 3. 2 is the box element. Minus m plus 1 and 1. Start from the box element. It will be minus 2m plus of 2. Change the sign. Plus 2m plus 3 divided by box element. Answer is 5 over 2. Fine. Similarly, you can find the rest of the numbers. And similarly, you can find this portion also. Previous number is my 3. Box element is 2. Other two numbers are my 2 and 1. So this number is my 6 minus 2 divided by 2. 4 divided by 2 is my 2. Fine. Why I skip this column? There are the two ways because already A1 is my leaving variables. Either you can delete this column. Fine. Otherwise, if you look about this sign, fine, whatever the value of the S1, the same value of the A1, provided the signs are my opposite. Half, it is my minus half, 0 sign is 0. Clear? Now repeat the procedure. What is the most negative value? Only minus 3 by 2 is the entering variable. Fine. Find the ratio. Find the ratio with the only positive value. So since this number is my negative, you can skip that. 2 divided by half is 4 and it's a 0. You can skip that. So which one is a living variable? This is my living variable. This one is my living variable and this is my box element. So you can skip the S2 and replace by the S1. You can skip the S2 and replace by the S1. Now write the identity corresponding to these three columns. S1, this is my 0 second column. S3 is my third column. Fine. This value is my identity. So it's a 0. Divided this complete row by the box element. So 0, 5, 1, 2, 0, 4. Can you write this column corresponding to the A1? Corresponding to the S1? This number is my opposite sign. Fine. Otherwise, you may skip that because A1 is already a living variable. Now, can you find the remaining elements? Again, by using the same rule, you can find these positions. For example, if you want to find this number, previous number is my 5 by 2. Box element is my half. So which other two numbers are there? Minus 3 by 2 and plus 5 by 2. So find the determinant, but make sure start from the box element. What is the answer is 5 over 4, change the sign, plus 15 over 4 divided by the box element. So what is the answer is 20 by 4, 5 divided by half. So that number is my 10. Similarly, if you want to find this number, previous number is my 0, 1 is a half, second is the 1 and 3 minus 3 by 2 is a 0. This part is my 0. It is my plus 3 by 2 divided by box element. This number is my 3. Clear? If you want to find this number, you can skip that because this is A1. Can you find this number? Previous number is my 3. One part is my minus 3 by 2, half, 3 and 2. It is my plus 3 by 2 and it is my plus 6 by 2 divided by box element. This number is my 9. Similarly, you can find the rest of the numbers and you can obtain these are the results. Again, look at the Zj minus Cj, whether there is any negative number. There is no negative number, so that means the optimal solution reach. And what is the answer of the x1, x2 and the maximization of the z? Now you can see x1, what is the final answer is 3. X2, since there is no x2, so answer is 0. Maximization of the z is my 9 is the correct answer of this problem. Fine. It's a very simple approach. You can complete the table in a very quickly manner. Once you understand that how you can pick the elements and you can see. That's why I'm asking you for more detail. You must watch about my this previous lectures solved example of the simplex method. Now let's start with the next problem. You can see in this problem, objective function is missing. Fine. You can see objective function is my missing. So how you can solve this problem? So I can choose objective function by on. So what you can choose? This is the 0x1, 0x2. Fine. And once it's a 0x1 and 0x2, then because of the equality, you can apply the big M methods. Then the first step is you can write in the standard form. So how you can write the standard form? Firstly, you can write in the constants. The first constant is 3x1, 2x2. Because it is of the equality, you have to write as a a1. Similarly, for the second constant, 2x1 plus x2 plus a2 is my 3. So because there are the two objective functions, so I can two artificial variables, I can use object as minus ma1 minus ma2, and the constants are x1, x2, a1, a2. All are my greater than 0. Fine. So objective function is maximization of z minus ma1 minus ma2. How many variables in this case? There are the 4 variables. So you can write this as the 4 variable. Substitute the value of the x1, 3 and 2. Value of the x2 is 2 and 1. Value of the a1 is 1 and 0. Value of the a2 is 0, 1. Value of the right hand side is 5 and 3. Look at the identity column. Identity column is my 1, 0, 0, 1. The column corresponding to the 1 comma 0, it is A1. So first column is my A1. The column corresponding to the 0 1, it is A2. So this is my A2. Fine. This is my A1 and A2. Now once you write as a A1, then you can write the corresponding value of this. This is my minus M. This is my minus M. What is the value of the x1? 0, 0, minus M, minus M. And because A1 and A2 are in the basic variable, this value is definitely 0. Then how you can find these three numbers? You can multiply them. Minus 3M, minus 2M, minus upper value. So this number is my minus 5M. Similarly, for this case, minus 2M, minus M, minus 0, minus 3M, minus 5M, minus 3M, because there is no upper number, so that will be my minus 8M. Fine. Now choose the peak value which has the largest negative number. You can think about M is my 100. This number is my minus 500. This number is my minus 300. Always pick from x1 to the A1. So this number is my entering variable. Fine. Once you will see this is my entering variable, find the ratio. Only those value which has the positive value. This is 5 divided by 3 and this is 3 divided by 2. Which one is the minimum? So this number is 1.7. This number is 1.5. So this number is my living variable. And once it's a living variable, so this is my common intersection. Fine. So that means you can replace A2 with the help of X1. Fine. Now again, this is my identity. The first column is my A1. Second is my X1. So I can substitute A1 is 1, 0. X1 is 0, 1. And this value is always 0. Fine. Now, this is the box element. You can divide it the last row by 2. It is half, 0, half, 3 by 2. Now, your target is to compute only these 6 numbers. Again, by using the box element, if you want to find this part, previous value is minus 3. 1 is the box. It's a minus 5M. Previous value is my minus 3M. 1 is the box and second is 1. इसी से आपका box बनेगा ना? This one. Start from the box element. So this number is my minus 6M plus 5M divided by the box element. So the answer will be minus M divided by 2. You can find this number. Previous value is my 0. 1 is the box. Second number is my 1. Third number is minus 5M. Start from the box element. Is a 0. Minus minus plus 5M divided by the box element. 5M divided by 2. Similarly for this case, 2 minus 8M, 3 minus 5M. So it is minus 16M minus minus plus 15 divided by the box element. Fine. Now look at this value. What is the previous value of this is 2. 1 is this box. So you have this 4 elements. Start from the box element 4 minus 3 divided by the box element. This number is my half. Can you find this number? Previous value is my 0. Then it's a 1. It's a 3 and 2. It's a 0 minus 3 divided by the box element. Similarly, you can compute the last elements. So this value will be my previous value is my 3. 1 is a 2. Second is this 3 and this 3. Start from the box element 10 minus 9 divided by 2. It is my half. So you can see once you have computed these numbers. Now look at the value which is the most negative. Since there is only one negative value up to the variable, you can enter to this variable. What is the ratio? So half divided by half is 1. 3 by 2 divided by 3 is my 3. And you can see the minimum value is my A1. So I can, and this is my box element. Fine. I can replace the A1 with the variable X2. Fine. Now this will be the identity element. First column is my X2. Second column is my X1. And I can put these values as my 0. I can divide it this row, that is a, I can divide it this row by 1 by 2. So 0, 1, it is my 2, this is minus 3, this is my 1. So can you find the remaining numbers? Again, by the same rule, by the box element. Fine. So if I want to find this number, previous value is my 0, 1 is a half, 0 minus half. So start from the box element is a 0 plus minus minus plus m by 2 divided by the box element. Answer is m. I can find this number. Previous value is my 0. Other number is half, half and 1. Start from the box element 0 minus half divided by half. It's my minus 1. I can find this number. What is the value of the previous part? 5 by 2, 5m by 2, half, minus 3 by 2 and minus half. So this number is my 5m divided by 4. This number is minus minus plus and minus. It's a minus 3m by 4 divided by the box element. So this number is my m by 2 divided by half. Answer is again m. How you can find this number? Previous value is half, half, half and minus 3 by 2. So that part is 1 by 4 and minus minus plus 3 by 4 divided by the box element. So it's a 4 by 4, 1 divided by half. That number is my 2. Similarly, if you look about this case, it is my minus m by 4 plus m by 4, 0. This number is 3 by 4 and minus 1 by 4 divided by box element. So 2 by 4, 2 by 4, that is my 1. Fine. Now you can see there is no negative values. So that means the optimal solution reach. So can you find the value of the x1, x2 and the maximization of the z? So what is the value of the x1? This is x1. The final answer is 1. Value of the x2 is 1. And the value of the z is my 0 is the correct answer of this problem. In your examination, you can check your answers as well. How? You can substitute the value of the x1 and x2 in the given equation. What is the given equation is? Here. You can see if I substitute x is 1, x2 is my 1. Is it satisfied? Yes. Is this equation satisfied? Yes. So that means yes, your answer is satisfied. Now look at the third example. I hope student you can like and comment on this video as well. Now you can see the one of the constant is the greater than is equal to sign. So yes, you can apply the big M method. So again, the problem is maximization. Remember student, if your problem is the minimization, you can convert into the maximization by multiplying with the negative sign. So I can write the constant firstly. So it is a x1 plus x2 plus 2x3 plus s1. Fine. Second constant is 2x1, 3x2, 4x3 plus, because only the equality there, so you have to use the artificial variable. Either you can use as a a1, fine, but I always suggested you, because this is a second constant, you can use as a a2. Otherwise you can use as a a1, there is no issue. Fine. Objective function is 2x1 plus 3x2, because there is a one artificial variable, so minus m. If you use as a a2, then you can write as a a2. If you want to use as a a1, fine, then you have to write as a a1. Fine. I use as a a2 because it's my second constant. Now how many variables you have? There are my 5 variables, so you can write these values. This is my right hand side. Fine. What is the value of the x1? 1, 2. X2 is 1, 3. X3 is 2, 4. S1 is 1, 0. A2 is my 0, 1. So which one? Because there are the two constants, your target is to form identity matrix. This 1, 0 is corresponding to the S1. 0, 1 is corresponding to the A2. So this value is my S1. This value is my A2. And Zj minus Cj corresponding to the S1 0. Zj minus Cj corresponding to the A2 0. Fine. Now, how you can find this number? What is the S1 in the objective function? 0. A2 is my minus M. Substitute here is my 2. The value of the Cj, that is objective function, 3, 0, minus M. Now, can you find this number? 0 minus 2M minus upper value. So that number is my minus 2M minus 2. Similarly, for the second case, 0 minus 3M minus 1. And the and the and the third case is 0 minus 4M minus 3. For the last case, 0, it is minus 12M here. So you can see these are the results. Now you have to choose the entering variable. Choose in your mind M as a very large number, say 100, or you may consider as 1,000. So first number will be my minus 202. This number will be my minus 301. This number will be my minus 403. So you can see that minus 403 is my entering variable. Find the ratio. 5 divided by 2, it is my 2.5, and 12 divided by 4 is my 3. So the minimum value is my S1. So the box element is my 2. So I can replace the value of the S1. I can delete the value of the S1 and replace by X3. Fine. Now this is the identity elements. You can write this is my identity. A2 is the identity. The value corresponding to the Zj minus Cj is always 0. Divide this row by 2. You will get as a half. This is half, 1, half, 0, 5 by 2. Fine. Again, you can compute the rest of the values. For example, I want to compute this number. So first number is my 2. Box element is my 2. Other two numbers are 1 and 4. Start from the box element, find the determinant. So this will be 4 minus 4 divided by 2. It is 0. Similarly, if you want to compute this number, previous value is my 3. Box element 2, 1 and 4. So this is my 6 minus 4 divided by 2 is a 1. How you can find this number? Previous value is 0. Start from the box element. So let me clear this. So it's a 0. It's a minus 4 divided by box element. It's my 2. What is the value of this? Last number is a 12, 2, 4 and 5. So 2 into 12 is 24 minus 4 into 5 is 20 divided by box element. It is my 2. Similarly, you can compute this number. Previous value is 0. You have these four numbers. 0 minus minus plus divided by 2. So I can say this number is my 2m plus 3 by 2. Similarly, you can compute the remaining 3 numbers. So you will get these answers. Now again, you can find which one is the most negative. This is the positive. Because this is the solution, you have to find the most negative value from these variables. There is only one. If you consider m is my 100, so this number will be my minus 99.5. This number is my 0.5. So this is my entering variable. Fine. What is the minimum ratio? This is my 5. This is my 2. So that number is my leaving variable, and that part is my box element. So that means I have to remove this number A2 and I have to replace by X2. Again, because this form the identity matrix, I can write X3 as the first column of the identity, X2 is my second column of the identity, and this value is my 0. Divided the last row by 1, so this number is my minus 2, 1 and 2. And similarly, you can find the remaining values. I can find this part. Previous value is half, box element 1. So these four numbers are my here. So the determinant is half minus 0 divided by the box element. So this number is my half. So similarly, you can compute the rest of the elements. I can do the one more for this case. Previous value is my 5 by 2. Box element is 1. Other two numbers are half and 2. So if you find this number is 5 by 2 minus 2 by 2 divided by the box element. Box is 1. So this is my 3 by 2. Similarly, you can compute the rest of the elements. You will get this is the answer. Again, you can see this number is my negative. So you have to enter through this case. What is the minimum ratio? Because this is my 0. So there is no minimum ratio. Only one minimum ratio is my 3. So this is my box element. And I have to replace x3 with the help of the x1. Again, you can write this is my identity element, and you can see I have repeating the procedure same. Divided this complete row by half. It is 1, 0, this is 2, this is my 3, and this is my 3. Why I remove this A2? Because the artificial variable in this case is removed. So there is no need to write this column again and again. So you can delete the column. Otherwise, if you don't want to delete the column, you can calculate these values again by the similar way by using the box element. Fine. Now, how you can find the remaining elements? Again, I can calculate one value for you. Previous value is my 0. Box element 1 minus half. So it's a minus half. Box element is half, 0, 1. Start from the box. It is my 0 plus half divided by the box element. This value is my 1. Similarly, you can compute the rest of the elements. Now you can see Zj minus Cj is greater than 0. So my optimal solution will be x1, x2, x3, maximization of Z. So what is x1? X1 is 3. X2, 2. There is no x3, 0. And maximization of the Z is 8 is my correct answer of this problem. Fine. In your examination, you can check your answer as well because x1 is 3, 2 and 0. So you can substitute in the given equation. My given equation is here. Fine. So x1 is my 3, x2 is my 2, x3 is my 0, and the value of the Z is 8. I can substitute all these values in the given equation. So 3 plus 2 plus 0, 5 less than equal to 5. Satisfied? Equality. In this case, 6 plus 6 plus 0 is 12. So yes, equality satisfied. And you can also see from this case, 6 plus 2 plus 0, 8 satisfied. Yes, your answer is satisfied. Okay, look at the last examples. I hope you understand this easiest way. Now, the last example for you is, if you look about this, whether the big M method is applicable or not. Definitely applicable because the constants are equality sign. But the most important thing is, if you look about these variables, what is the nature of the x1? Whether the x1 is greater than 0 or x1 is my less than 0, it is not given. What does the meaning of that? That means x1 is my unrestricted variable. Once the variable is my unrestricted variable, how you can solve the problem? You have to replace the x1 with the two positive variables, x1 dash minus x2 dash, such that both the values are my positive. Fine. I can substitute the value of the x1 in the given equation. Fine. Once you can substitute the value of the x1 in the given equation, your equation will be here. Now, all the variables which are present in this given LPP are my greater than equal to 0. Hence, you can apply the big M method. Why? Because the constraint is of the equality sign. Fine. Now, you can write in the standard form. First of all, if you look about the constants, it is my 2x1 dash minus 2x double dash plus 5x2 plus x3 plus a1 is 12. If you look about the second constants, x1 dash 3x1 double dash plus 4x2 plus a2 is my 11. And your objective function is 3x1 dash minus 3x1 double dash 2x2 plus x3 plus a1 plus minus ma1 minus a2. Fine. and all those variables are my greater than 0. But how many variables in this case? There are so many variables, but I will tell you the one way. Look at the constraints. What is the column corresponding to the x3? 1, 0. Fine. And the column corresponding to the A1, 1, 0. Column corresponding to the A2. So you can see if you try to form the identity matrix, they both are same. Fine. If both are same, then there is no need to use the A1. It will reduce your calculation. There is no issue. बच्चों आप अगर लेना चाहते हो A1 ले भी सकते हो. There is no issue for that. Fine. But if you want to reduce your calculation, because you can see x3 and A1 are similar value. That means whatever the column of the x3, the same value you can obtain in the column A1. Fine. So my advice is once you can form the identity matrix, there is no need to write as the A1. Because A1, the behavior of the A1 will work as the x3. Fine. That will reduce your calculation. But again, I can tell you, you may use as the A1 as well. Now, I can write all those variables in this case and calculate this value. Now you can see this is the identity column. X3 is my identity column first. A2 is my x3 is my 0. A2 is my 0. Fine. Now how you can compute the values? X3 1 a minus m. The value of the Cj is 3 minus 3 2 1 minus m. So it will be my 2 minus 3m. Upper value is minus of 3. So this number is minus 3m minus 1. Similarly for this case, minus of 2 plus 3m. Upper value is my minus 3. So it's a plus 3. So that number is my 3m plus 1 and so on. Fine. One more way you can think about the problem. You can see about these values. That means if the coefficient of the x dash is my 2, this is a minus of 2. If it is a 3, it's of the minus 3. So that means whatever the value you have obtained corresponding to the x1 dash, the negative value you can obtain in the column x1 double dash. The meaning is, if I say this value will be my minus of 4, then this value will be my plus of 4. That will reduce your calculation very well. Fine. Anyhow, now you can find the entering variable. Think about m is my largest number, say 100. This number is my minus 103. This number is positive. This number is my minus 397. So that part is my largest part. So this is my entering variable. Find the ratio. 12 divided by 5 is a 2 point something. It is my, so first number is 12 by 5. Second is 11 by 4. Which one is the minimum? It is my 2.4 and it is 40 over 8. 30 is 2.75. So this part is my minimum. Fine. So box element is my 5. Fine. So I can replace the value of the x3 with the variable x2. I can write for you here. Fine. I can write as a x2 and this is a2. Fine. Now because this is the identity elements, x2, this is the first column, a2, second column. The value corresponding to them is 0. Divide this row by 5. So 2 over 5 minus 2 over 5, 1 over 5, 12 divided by 5. Fine. Now you can find the rest of the value. Say for example, I can find this number. Box element is this 5. I need a 3. 1 is my 4. Second is my 2. Start from the determinant. You can see it's a 2, 3, box element 5, 4. Find the determinant, start from the box element. This is 15 minus 8 divided by 5. 15 minus 8. So 7 divided by box element. This is 7 by 5. If this is 7 by 5, then this will be my minus 7 by 5. There is no need to compute them. Similarly, what is the value of this? Previous value is minus 3 by 5. Fine. Then 2, 5 and minus. So start from the box element. Minus 15m minus 5 plus 8m minus 6 divided by box element. So this number is my minus 7m minus 11 over 5. Minus 7m minus 11 over 5. This number will be plus 7m plus 11 over 5. Similarly, you can compute these four numbers. Now look at the which one is the most negative value. Only a one negative term. This is my entering variable. Fine. Which one is the leaving variable? 12 divided by 5 and 2 by 5. This the first ratio is 6. Second ratio is 1. So this is my minimum ratio. So this is the minimum ratio, means you can replace the value of the A2 by x1 dash. Fine. Clear? Then this will be my identity elements. So x2, x1 divided this row by 7 by 5. Now once A2 is removed, so you can skip the column. There is no need to write this column. Otherwise, if you want to write, you can compute the values. There is no issue. So now you can compute this part. What is the previous value is? Minus 2 by 5. You can take these four numbers. Find the determinant. Minus 14 over 25 plus 14 over 25. So 0. Fine. Similarly, you can find the other numbers and you can get these results. Again, you can see this number is my negative. So you can enter through this. If you want to find this number, you can do that. Like, what is the value of this part? It's a 5 over 7 because you can divide by 7 by 5. Previous value is 0, 7 over 5, 2 over 5, and this. So this number is my minus 2 over 7. Fine. Now, what is the minimum ratio? Because this number is my negative, so second value you can't find the ratio. So only number is my 14 by 3. So this is my minimum ratio. Replace the value of the x2 by x3. Fine. So if I replace the value of the x2 by x3, then this number is my identity, x1, second column of the identity, and the value of the zc minus ej is 0. Divide this row by 7, 3 by 7, 0, 0, 7 by 3, skip, and it is 14 divided by 3. Fine. Then rest of the value you can compute by the determinant method. Now all those zj minus cj are my positive. So therefore your optimal solution is x1 dash is 8 by 3, x1 double dash there is no value, is a 0, x2 there is no value, x3 is my 14 by 3, and maximization of the z is 47 over 3. But your target is to find the value of the x1. What the initial assumption you have taken? X1 is, so you can substitute the value. X1 is 8 by 3, x1 double dash is 0. That number is 8 over 3. So your answer is x1 is 8 over 3, x2 is 0, x3 is my 14 by 3, x maximization of z is 47 divided by 3. Again, you can check your answer. You can substitute in the given equation and check whether they are satisfied or not. I hope you understand this lecture very well. I give these 6 examples as an exercise for you. You can see that the first problem is your minimization. You can change into the maximization. That will be minus 3x1 plus x2. Fine. And after the solving, if you get the maximization of the z is, say, what is the answer is 9. Fine. Then what is the answer of the minimization of the z is minus of 9. Fine. Again, this problem is the minimization. You can change firstly into the maximization. This is already a maximization. Change into the minimization. Change into the maximization. Maximization. And you can see this is the equality sign. Yes. And x1 is unrestricted. There is a one constant greater than sign. There is a one constant greater than equality. You can use the big M method. In this example, none of the constant is greater than sign. So that means in this case, you have to solve by using simplex method. Fine. And once you can solve all these problems, you can verify your answers as I mentioned here. Let me know in the comment box how many of you have get these answers and how many of you have understand this lecture very well. I hope student you can like and comment on this video so that it will be reaches to the many students as well. We will see the next lecture very soon on the two-phase methods. I will solve the same problem with the help of the two-phase method. Till then, you can share this video with your friends and don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning always.